Welcome to the Be a Maker Club podcast. Today we have a very special guest. His name is Todd. He's from the nonprofit Tinker Tools, which is a digital platform that is building free tools for creating new laws. Hi, and welcome, Todd. Please tell us a little bit about yourself and Tinker Tools.
Well, thanks. It's great to be here with you. I love your podcasts. They're great.
Thank you.
I'm excited to be part of them. So, we Thinker Tools has been part of my life for 25 years, and before that, it was around for another 15, 20 years. It started at MIT as originally a game system for helping students understand physics problems, so they could. It was like one of the original computer games for learning. And over the years, I've been part of I was at grad school with the Thinker Tools research group at Berkeley, and we developed several tools, primarily digital, but also some physical tools for learning. And eventually, I'm already old, so the people that started the program were even older, and some have passed away, and so I've kind of inherited all of the Thinker Tools platforms. So I said, well, what am I going to do with it? So I decided to create a nonprofit agency rather than selling all of our products. It seemed like a lot of it was built with grant funding, NSF, Spencer Foundation. I could go on and on. So I decided that let's get them out for free.
Okay, wow, that's impressive. So you already had the tools already set up, or was there just IP that you then converted into tools?
Well, a lot of it was set up, and a lot of it's old code that we're right now we're in the process of redoing all of our code.
Okay, well, tell us a little bit about that process. What was that like? So what was the old code, and what's the process to convert it to new code? Like, are you actually hand coding it brand new? How are you doing that part?
Yes, we are hand coding a lot of it for web applications. So a lot of it was initially Java, and a lot of Java coding. I'm not personally, I'm a great prototype coder. Would not consider myself a professional coder.
Sure.
We've hired some professional coders to help us along the way, and I've learned some along the way. But now we're doing it all online. JavaScript, a lot of JavaScript, a lot of PHP, some Python,
right?
Whatever's on the web, we can grab and do. But it's been a 4-year process of developing prototypes, testing them, upgrading the code. We just had to upgrade the code quite a bit because PHP went to their new level of the language, 8.3, which is great for security. We had to go through all of our code
again,
so that took a couple of months. And now we're kind of like a 40-year-old startup, so we're ready to push out our revised platform in 4 to 6 weeks. So that's thinkertools.org if you're interested in trying it out. But we've had some designers. We've done a lot of pre-testing with prototypes, but we haven't. This new version, we're still kind of testing it out as we go and getting ready to push it out. So it's kind of exciting, but also a little bit stressful, as you know.
Of course, yeah. So wait, we're right now in August, so or the end of it. So we're talking maybe first, second week of October, potentially.
Yes, potentially. Yes, I hate to put a hard date on it.
I know. I've been part of startups. I completely get it. But that's
October.
If you had to describe this to a layperson, how would you describe Tinker Tools, the platform? Like, what does it do? How can say, and especially because you're pushing it out there for free, what benefit can a person have when they visit tinkertools.org?
Right. Our model is Wikipedia. So Wikipedia is a free encyclopedia. It's current knowledge. It's whatever is out there currently, what people know. It's all user-generated content. So they have editors. People can join Wikipedia and be an editor. So there's a lot of checks and balances by having all of these people working on it, as well as tapping into all this knowledge that's out there, rather than having a few writers and editors writing a new encyclopedia. So it's free. Wikimedia Foundation is the overall. So we're kind of like Thinker Tools is like the Wikimedia Foundation. So we're the overall
Gotcha.
um, corporation that finances it, does all of the hiring of people. But we're counting on a lot of people to use it in their daily life. So if you want to know something right now about something, you can go to Wikipedia and find out. But if there's something that's not known yet,
Mm-hmm.
where do you go? And how do you build this new knowledge? How do you
Right.
create the knowledge?
Right.
What's a person supposed to do, or what's a team supposed to do? We found out there are a lot of structures of knowledge, current knowledge. A knowledge structure could be something as simple as a list. What's a list? Everyone knows what a list is, but a good list has has multiple items, right?
Yep.
Each item should be stand on its own. It should
Mm-hmm.
be conflated with other items. All the items should be kind of similar in scope. So there's some kind of rules
Right.
that you would follow
Yeah.
to develop a good list. And how do you actually physically build the list? Well, you make a move. You add an item. You can split an item. So rules and moves, and you have an object is the list. So you put all this together, and what do you have? You have a game. So
Okay.
one of our platforms is called the Web of Inquiry,
Mm-hmm.
and these are games to create new knowledge. So everyone kind of has a basic understanding of a game. As a kid, you know what a game is.
We played games, sure.
You make up your own game as a kid usually, so you understand kind of the basic structure. But if you go to it's like, this is kind of based on epistemology. So you tell somebody, hey, you can go to our site and do some epistemic form for creating some new knowledge. People are going to not understand what that is. So the game structure, people know, oh, so I can play a game to develop something new knowledge. Say you're interested in a new field called, let's call it pandemic psychology. Which is
okay, because the incident never happened before, so it's logical to assume that the knowledge related to the incident wouldn't be present.
Exactly, right. So how do we build this field? How do we build this knowledge? Well, we can play a game like let's start with a list. What's a pandemic? I mean, you can actually define by playing this game called make a list of what is a pandemic. You can do compare and contrast. Say what's the difference between pandemic, let's say difference between COVID pandemic and flu. You can create a compare and contrast table. That's a game. You have constraints, you have rules, you have moves you can make. People, you're working with your team, you can take turns. You could even have maybe a competition with another team who could build the best list of the COVID pandemic factors. You could also look at it. Well, how did it start? Right? How does a pandemic start?
Yeah.
It's still kind of a mystery, right?
Yes.
not counting the misinformation and all of that. But you could go to Wikipedia and say, "Tell me about the pandemic," and there'll be a lot of facts. How do people react to it, and how we can do better next time? That's like building new knowledge. So we're providing all these. Let's say the Web of Inquiry is a way of structuralizing that field to further the knowledge of that field, as well as to provide holes. Discover what the holes are in the knowledge. What do we need? We may have to set up a new kind of game to figure this out. So the tool itself allows you to build new games.
Okay.
So you can create a new game. And as part of all of this, today things are done but with teams. It's so hard to have this one genius person who solves all the problems, right? There isn't really.
There isn't, yeah.
So as we've been doing Thinker Tools over the years and working with teams, we realize that teams are dysfunctional in a lot. Usually, they're not completely functional, I should say, without some training or some idea of how well you're doing this. So another one of our tools is to help people collaborate while they're doing games, while they're playing games. We've kind of we've been looking at a lot of aspects of this building new knowledge. The other thing that we're doing is also that knowledge is not always in the heads; it's embodied. It's like we do stuff with. We actually physically
like
have
actions and skills and behaviors which
skills.
follow certain patterns.
Exactly, right. So we're looking at helping. We're helping people get over this learning curve. You know,
Right.
this learning curve of understanding what knowledge is. How do I use this to solve a problem? If they can start up here, they're farther along on this on the curve. So we're helping people push up to the curve, push them up the curve a little faster.
Yeah. So in your example, you talked about the pandemic knowledge, like what is a pandemic, or say how it can be solved, or maybe those are the inquiry lines. But that's still a pretty, like I'd say it's a higher level topic.
Yes.
And if you go on Wikipedia or popular content. So what about pop culture? What if somebody was interested in pop culture, not necessarily scientific knowledge?
Absolutely.
Could they also potentially use this? I mean, if they wanted to, I don't know, learn about celebrities, one of the more banal and really sometimes funny things. I'll repeat the question. So yeah, this is the example you gave was mostly around the area of scientific knowledge. Yes, it was related to the pandemic. Right. But what about if somebody wanted to either learn more or actually build more knowledge about current pop culture, something trivial, something that's not actually of any consequence except for just self-entertainment purposes, learning about celebrity lives or predicting what type of movies a celebrity might do next. I mean, would a platform like this be able to create new knowledge around that?
The short answer is absolutely yes. So if you talk to Wikipedia, what's your number one area that people go to Wikipedia for? The celebrities.
Yes.
Admit it.
Yes, of course.
So they're not going there for organic chemistry or well, I do, but not everybody.
Not everyone does.
Not everyone does. Yeah. So our tools are totally free of any kind of domain area constraints. So, for example, I'm also a fiction writer. So I write novels, publish novels. I'm an editor. So I'm always interested in how people consume literature. Right. What makes it satisfying for them? So we could create a game like, why is manga so popular? Why is it so popular? In not just Japan culture, but Western culture. Like you go to Barnes and Noble, and there's rows now of manga. Anime, go into their video section, and there's a whole row of anime. Yeah. And so, why is that so popular? Why is it that touched a lot of non-Japanese societies? I don't know the answer to that. I wish I had started writing manga before I'd write my literary fiction, which has a nice audience, but it's not like this huge global phenomenon. So the web of inquiry could create an inquiry game like, why is manga so popular?
Right.
Yeah. Wow. Why is J-pop so popular? Why is K-pop so popular?
I could decipher using this tool. I could decipher the popularity bits because I mean, in theory, if I were a new writer, or maybe just somebody who says, I want to write a new book in fiction. But I want to understand what is popular. So I want to write something that is also going to be commercially successful. So you could potentially use Tinker tools to go down that line of inquiry as well.
Absolutely. Somebody may have already done that. When you go to Tinker tools, you could type in, how do I write? Why is manga so popular? And someone may have already done a game.
Right.
Someone may have already done a game, and that's on a line that you can look at. But there could be like a list of like physical features of a manga, like it's a comic style.
Of course. Yeah.
And so the characters, you're just looking at some still image with some words. What are the character traits that make it so popular? So you could break this down into various pieces. You may have to create a new game. Well, like why is a certain topic in manga love or loss or grief, or you could look at various
types of
various types.
So I think one of the obvious questions that are popping up in my head right now is how is this different from generative AI? Because the at least what the popular perception right now seems to be, you could ask generative AI any question,
Mhm.
literally any question, and it creates an answer for you. So if you had that now available with ChatGPT, Gemini, how
Right.
is Thinker Tools going to be different, or how is it different from something like that?
So there will always be tools and technology out there that will help people learn, or people create something, or people to do something. AI is the current tool, and I've been doing AI myself for
Right.
25 years. So I'm not saying that it's going to be something that will take over the world completely, or it's not going to do any good. So I'm kind of in the middle of all of this
Sure.
kind of argument about it. But people, we need to understand how the tool works, how AI works. I use it a lot myself, and it's always, for me, I always find it lacking in some way. And you can train it to do better and better.
Yes.
Yes, right, right. But it doesn't. It's something that can be a tool to help you build new knowledge. Yes, I think that Thinker Tools itself is all based on how people learn, how people create, how people understand, how people reflect on their processes. So it's more of a personal, humanistic kind of approach, but we're also cognizant of the recent successes and of AI, and we are obviously going to incorporate AI in some way in Thinker Tools itself. We've already looked at having AI analyze discussions. So part of our collaboration tool helps people analyze their discussions to find weaknesses and strengths. AI can be a part of that.
Okay.
But as a tool to help you improve yourself,
right?
Improve your teamwork. Same with building new knowledge. We can have AI look at the games that are being played on the web of inquiry and see which ones are related or which ones conflict. So you can compare a similar game or one that's conflicting. AI can help you. So if you have a question like how do we build a field of pandemic psychology, or how do we build a better raised garden?
Okay.
Something more concrete, maybe. How do we build a better raised garden, right? We can, you may not know where to start with that, but AI can help you. Oh, let's start with a list building tool. What are the components of a raised garden?
Right.
So the AI can help you get started.
Right.
Right. And it can also help you analyze data. Say, for example, I built my raised garden. My tomatoes are suck. My my cucumbers are. I got too many cucumbers. I have no tomatoes. What's going on? So you can ask a question of why are my tomatoes not growing well in my raised garden? And AI can say, oh well, look at this game. These people over here played this game of soil type, pH, to see what the differences are between growing cucumbers and tomatoes in the same soil. So look at that and see if that will get you started answering your question. How can I improve the soil to make my tomatoes grow better? So AI can be a tool in all of these, and we have to incorporate it. We have to incorporate it. There's no reason why not to. But on the other hand, we need to be able to reflect on the AI and personally, is it giving us good advice or bad advice?
Right.
How do I analyze that? I was just talking with a poetry professor at one of the colleges, and AI, of course, is a big. When you're turning in you're turning in your essays or
assignment,
the first thing they think about is did this student really write it,
or is it AI
generated? So, but how can you use AI, and they said, well, it's there. Well, same way with Wikipedia. When that first came out, that was a big hue and cry. Well, people just be copying and putting in, there's still, it's the argument's always there.
Yeah.
A lot of it's personal integrity, or we have to understand that some people are in that class to really learn. Some people are just trying to get out of the class, just get that requirement out of the way, or there's motivation. There's a lot of human involvement with AI, I think, that we're still trying to figure out. But you could also use it, like the professor could write, so we had AI chat GPT create an essay about Thomas Mann's Magic Mountain or whatever, a poem, read this and critique it. What's good about it and what's not good about it. So there's a lot of opportunities, I think, to use AI in the right ways. What I guess the bottom line is.
So, I mean, a lot of our listeners are also interested in the making side of what we do, right? And so how would you say, because this is part of your agenda, I know we've discussed it offline as well, where you're looking at spaces. So how do you think Tinker Tools can help people create new things, new products, maybe? And what would be, so what's your, I guess, your vision for that, or some things that you're trying to put in motion to help people make things?
Yes, I think our main goal is to create spaces or work with existing spaces that incorporate our learning, reflective, knowledge building models.
So can I clarify, when you say spaces, you do mean, or you're referring to maker spaces?
Yes, right? Maker spaces, physical spaces. Maker space. We call them thinker spaces. That's part of Thinker Tools. So, for example, we did a after school design club for kids. So, for example, building I think we actually did a raised garden thing for a Lego character.
Okay.
So we introduced the students to design concepts rather than just throwing them into the system, into the project, which has its own, maybe have its own benefits too. But we were providing them a little background in design. So rather than starting with the solution, you actually start with a plan, a vision, a question, like how is this garden going to benefit the Lego character? So then that starts a little bit of more of a design, classic design process where you model something in your head, that you build prototypes, you test it, and then, how does that work? So we introduce them kind of the basic cycle. Mm-hmm. And we also provide ways of reflecting. So rather than just zipping through things, we provide little moments of reflect, like how did this really satisfy Mr. Lego or Mrs. Lego?
Wow. Okay.
So we provide that. We've always the whole theoretical thing is based around metacognition. So kind of regulating and understanding your own thinking process, as well as social, meta-social cognition, understanding how you're interacting with your teammates or with them, or even if you're solving some community problem, who are your users. So we kind of overlay this on the maker space. So I think what we're interested in doing, we don't have a physical space right now. And we could open one, but there's so many out there already. Yes. In fact, I would love to hear from your listeners about, hey, we'd love to get collaborate with some actual people who have maker spaces, help us see how we can integrate our theory of learning and knowledge building and design and reflection and teamwork and all these other kinds of skills involved in that. Yeah. And we are in the process of applying also for some grants to further our interest in this area. So we have some possibility for some funding if we get the grants with some collaborative. But we'd love to have a community of maker spaces that help work with us. I don't know. I know a few maker spaces, but I'm not really tied in with the community. So how do you feel about the local community aspects of maker spaces? is there ever like a meeting of all the makerspace people and say, hey, this is what we're doing. We've had success. We have this tool in case you need that, or you can send us over there for doing this. Do you have some curricula that you share or instructions? I don't know. Is there a group?
So, I mean, I would say like the short answer to that is that the yes to all of those questions. The good thing is that there's recognition that makerspaces are important. How they're important, I think, is not quite established, or where they're specifically important.
Right.
I used to run a children's makerspace, and we work with elementary, middle school kids. So at that stage, it was easier to assess some impact as they acquired technical knowledge, for example, or they were able to turn some ideas into physical objects.
Right.
And so it was clear to see, okay, they've acquired some skills of problem solving and thinking through challenges and dealing with that. But when it comes to bigger problems, like I'll give you for instance, and one of the reasons I'm so interested in your platform is consistently maker spaces have expressed, and I've been in the makerspace world and I've networked with a lot of makerspaces. So before that, though, let me just give you a quick rundown of types of makerspaces.
Yes.
You have private membership makerspaces. They work exactly like a gym. You pay a fee. It's a for-profit organization, and so they have us as long as they have a returning amount of members that give monthly dues, the makerspace keeps going, right? But you pay for most stuff. The second one is nonprofit makerspaces, which really depend on either a large donor or a nonprofit or some other sort of method of fundraising, and they subsidize the cost of both the actual materials, but also the learning, which is probably the most expensive part. And then now, which is I think is very encouraging, now there are library makerspaces.
Oh yes,
which are available at your local library, completely for free. However, they're like libraries, that their resources are very limited, and there's very small amount of things that you can do. Some have lasers, some have 3D printers, some will do a Cricut, which is a simple tool to cut stickers or vinyls, right? So it's limited, but you're still able to at least get started. And then, of course, you have the educational makerspaces, which are either in schools themselves or colleges, and they work along lines of organizations themselves. So whatever rules the organization has about liability, times they can be open, etc., etc. By far, one of the common issues with a lot of these is both on the maker side, so the individual wanting to run, but also on the makerspace side, is how do you get them started so that they get the best out of this? And this is like kind of like a question like how long is a piece of string, right? Because different people have different approaches to working, and so I'll give you the sort of more concrete example where a person walks into a makerspace and says, oh, you know what, I want to build a brand new bookshelf because I have this kind of house and it needs to look like this. And so the makerspace says, okay, I have all these tools. There's a bandsaw, we have a laser cutter, we have a CNC. And the guy goes, okay, that's fantastic. How do I make the bookshelf? Which really indicates that this person's never made anything before. So they have no idea. All they've seen is like a bookshelf, right, in their house. And they think, oh, because I can buy a bookshelf, the process of making will only be slightly harder than this, but which is not true, right? You probably have to like learn engineering. Like, I mean, there's so many other disciplines. And so this is really, in my mind, at least, your platform address something like this, because this, I feel, is a critical problem. It also creates a lot of issues, and especially in smaller community makerspaces where you might have someone who's an expert within the makerspace, like really very good, and then they get annoyed when somebody just like completely a novice, has no knowledge of what challenges to expect, walks in, because in their head they're thinking, well, I've spent 30 years and I went to college for engineering, and that's how I know how to make this bookshelf now. And you're expecting to walk in here and be able to walk out with this bookshelf, like so you can kind of see where the conflict is. And so this is a real problem.
Absolutely,
it happens. I would say in some form or the other in all makerspaces. So of course, when we were working with children, it was different because we scaled down the approach, and we were dealing with really tiny outcomes in
Yes.
terms of the physical product. So
Sure.
it was achievable
Right.
for us. But the minute we looked at how do we scale this, or could this be applied to adults,
Yes.
we ran to all these problems.
Right.
So I'm
Yeah,
just
yeah.
kind of setting the scene.
Absolutely.
And so I feel like so I think this might be a really good area to explore. And
Yes.
if your tool can offer a pathway for people in this situation, I
Yeah.
think it's going to be there's a ready-made audience there.
Oh, that's great. That's very helpful. Yeah, that kind of summarized the problem space really well, which is, as a researcher, I'm always interested. What's the problem space? What do we have to deal with? And so that really helps a lot. That's exactly the kind of problem we're trying to solve.
Okay, fantastic.
Makers, and not only makers, but also knowledge building. Somebody wants to come in and doesn't know anything about it, but they have this problem, or they have this desire, they have some curiosity about something. How do they get started? How do they find the experts? For example, this, speaking of bookcases, this little Japanese style bookcase over there called a tansu. Was designed for Japanese staircases, so it's kind of built like this.
Right.
So I'm really bad at woodworking, but in furniture design I know nothing about. But I went to a friend of mine who's an architect. He does a little furniture design. I go, hey, I want to build this tansu for underneath my staircase. It's a Japanese style thing. He goes, oh, let me look at it. And so he looks at it, and he grabbed that little model on the top there. I could show, it's a little balsa wood kind of model, and that's like the third generation, and we tinkered around with it. And it says, how does that look? I go, that's exactly what I want. It's got some shelves, but some doors and some open, and I can put books and displays. So, but I wouldn't know how to build it. And he goes, well, I don't know how to build it either, but so we found a guy who built the carcass, the box part of it, but he couldn't build the doors. And so, because the doors are a special wood with hinges, and they have to fit right. And I couldn't do that, so we had to find a door. So what I'm saying is that it's a matter of finding not only having a vision about something, but also finding the right tools to use. Because I didn't have the tools, he didn't have the tools, but we found people that did. We found it's it's almost like a machine shop. I guess we used to call them machine shops instead of maker spaces. And we had to understand like the physics of what was going to be actually on those shelves to make it sturdy enough. Right, what kind of wood you're going to use? How you're going to connect it without showing the screws? And the one on top just kind of sits there. How is that going to build in? So it's and by the time we were done, we had all this knowledge. I had built up all this knowledge of furniture design and wood and tools and connectors. It all starts with some little thing, and you may not know anything about it. But so that's kind of what our idea is: building a template for having this work together with a community of maker spaces, a community of classrooms, a community of just ad hoc teams. It could be a neighbor, or it could be just your local neighborhood group who wants to solve some speeding problem, or some sharing fruit, because our neighborhood is full of fruit, but half of it rots on the trees because nobody wants to come and share it. So there's countless ways of integrating what our kind of methodology is on existing communities. So we're excited to work with maker spaces too. And if anybody wants to work with us, we're happy to get involved. And like I said, we're setting up some digital tools that will help that process. And like I said, speed up the learning curve on our experience in research, as well as being in classrooms, as well as being in ad hoc groups, how we've seen effective learning happening, effective collaborations. So if you got the crusty old retired engineer who knows what he can do, but he can't really bring somebody new along. There's just too much. There's too big of a gap. We're trying to help close that gap with our tools. We're excited to bring this out into the world and collaborate with real groups of people. And please contact us if you're interested.
A lot of things that we buy in the U.S. today are made in China. even small things. And
Right.
people think, oh, because it's cheap, this must be simple or easy to make, right?
Right.
And then when they try to duplicate that, they quickly realize, oh, I don't have the rigs, for example, like, something that's a million pieces they're made. That's usually, say, for example, if it's plastic, it's injection molded, which is like a huge process.
Yeah.
And so to duplicate that requires a deep level of engineering knowledge that
Right.
just because you're using the tool in a very sort of
Yeah.
hands-on way or a
Right.
simple way, that does not mean it was created
Yes.
in that manner.
Mm-hmm.
And so I feel like this is really a problematic area, because
Yeah, it is.
more and more people now are realizing that, hey, we should know how to make things,
Mm-hmm.
or at least, at the very least, we should understand how these things are created. And I know I'm referring to physical tools, but definitely in the area of food, this has become
Absolutely.
a critical issue,
Yes.
right?
Right.
People really want to know where their food comes from, what's in it,
Mm-hmm.
and how
Yeah.
to either cook it or acquire it so that
Right.
it's nutritional value.
Yeah.
So I'm
Listen,
super excited. I think this is gonna, specifically going back to makerspaces, I think this can really be valuable.
Great. Yes.
Especially like when we talked about your example, because when we used to teach kids, I kind of broke the pedagogical process down into some very simple steps.
Mm-hmm.
I used to talk about the first step being idea.
Mm-hmm.
And how do you capture the idea?
Mm-hmm.
And of course, we were dealing with kids, so we used to pen and paper,
Right.
and we'd make scribble sketches.
Yes.
And then we turn that into a CAD design.
Mm-hmm.
And once that CAD design
right.
was made, you could clearly see from the sketch. So for example, they usually like superheroes. And so the physical human form is very complex to physically recreate.
Mm-hmm.
But in the sketch, they would have the human form.
Right.
But when it came to making the CAD design,
mm-hmm.
they focus on things like symbols.
Oh.
Or things that are iconic about the superhero.
Oh, right.
And then when they say 3D printed that CAD design,
right.
They would only color one or two colors. Like, I mean, Captain America, right? So if they look Captain America, they would just do the concentric circles and the star. Because that was the most achievable thing within their skill set.
Sure.
As they grew older,
yes.
their skill set started to grow as they acquired new knowledge.
Yes.
So I mean, if you expounded on that, how would, say, Tinker Tools fit into somebody's learning journey as they went through school to college? Sort of potential vision you have, or are there thoughts that you have on that?
Yeah, so Tinker Tools, our platforms are designed to be age generic. So we're not looking at any specific age group. We're not looking at, we're trying to make it as accessible as possible to all ages, all learning styles, all specific domain questions that you may have. So I would hope that it would be able to follow you through as you got more and more I guess, complex in your thinking and the problems that you're trying to solve, the complexity. We're looking at a lot of ways to resolve complexity, help make it more visible, while not reducing it to some simplistic kind of solutions. But so the Tinker Tools, originally, the original Tinker, we were looking at science education in upper elementary, primary school ages. So it's very specific. And we were looking at the scientific inquiry cycle. So learning science along the way of, say, building a solar oven. What are the scientific principles behind? So maybe if you took that class and you were in upper elementary, now you're probably just graduated from college. You want to start a startup in this idea. We have a climate issue, a climate problem. We want to reduce our carbon. And you're thinking back, we built this solar oven when I was in 6th grade. How can I turn that into a business? So I think you could go back to your web of inquiry, look what you did, and say, that's how the basic fundamentals of it, but it doesn't scale up, or you can't really. Maybe you want to cook a pizza and you need to heat it up to 900 degrees instead of 250 degrees, or however hot it got in your solar oven. So, but then there's new materials, design. So everything is going to keep evolving, keep changing. Materials, tools, knowledge. So the Tinker Tools is built to fundamentally handle that kind of scaling up, evolving of knowledge. So we're helping build structure. So, Charles Darwin, he wrote The Origin of Species, right?
Of course.
But a lot of, even he admitted, a lot of the details in this book may be turned out to be incorrect. But what I'm setting up here is a structure, a framework for understanding how species evolve.
Right.
Then it's testable. You can actually test things and see what's right and what's wrong about it and modify it. So Thinker Tools is built on those kind of basic structures of knowledge that are generic, but you can use for specific cases, or you can use them in a different situation. You can create your whole new model of what news. Maybe we just found out recently about dark matter, right? What is it? We don't know what it is. So we need a whole new structure of understanding matter and energy to understand dark matter, and dark energy. So somebody could go in and create a new game called Understanding Dark Energy, the platform. So it's designed to perpetuate as well as create this kind of web of knowledge. So things are, when you finish a game, it automatically looks to see what other games, like I said, what other games. Yeah. So you kind of build this constellation or galaxy or critical mass of knowledge that kind of be changed. And then somebody could poke at it and say, oh no, I think we're missing this piece here. Let's do this game over here. See if we can plug that hole up. But from what it started out as a real specific kind of tool, we've made it more and more fundamentally generic and more powerful because it can handle all those different parameters and different ideas, and it doesn't deny creativity at all. You can be very creative in playing your game or create. There's no. It's not a zero-sum game. In other words, you're not going to lose your house because you lost the game or anything. It's more of a cooperative kind of game.
Right. Like a learning social network.
Yes.
So where your learning is completely not just self-driven, but also mood-driven to some extent. Like, so I'll give you, for instance, like I had a Scottish professor who eventually became a good friend of mine when I was doing my master's in the UK. And he used to tell me that when he was really young, because, a lot of Scottish villagers had sheep and they'd make wool yarn.
Yeah.
So he says one of the games he had, was a game for him, but he said it was an economic necessity. They had to make yarn, and so the way they did it was they would it was kind of like a spinning top, which didn't touch the ground. So he said walking back and forth from school, I had to play with it. Right. But what he was doing was essentially turning that sort of wool that was in a school bag into yarn. And so it was a game for him, but he essentially created yarn, which would then be used to create wool fabric that the family could sell. Right. And so I feel like what you're saying sounds kind of similar to that, in the sense that you're playing, but then you're also learning valuable skills that you can potentially grow and expand. Is this? I mean, does that sound right?
Absolutely, that's very true, right? So, like I said, we all understand what a game is, and it's kind of a game is engaging for one thing. You're interested in playing this game because you're seeing what the impacts are. And you're usually in some kind of psychological cognitive state where you're paying more attention to what you're doing. Other things are, you're not being distracted, so you're focused more also in the game situation. And you're also able to, so like maybe he went too hard once and it hit the ground and all this, the yarn exploded.
So those kind of things happen.
So you're always but then you're open to surprise, and you can, okay, that didn't work. Let's try something else. Or you could, maybe if you're ambidextrous, you could maybe start doing two at once, and then your friends are walking by and go, hey, that looks like fun, and then you could offload your work
to them.
Right. So So there's a lot of good things about the gaming aspect of it.
Yeah.
I think that.
Well, I mean, I feel that there's also, I mean, yeah, you're talking more about the gaming aspect, but I was also talking about how this notion or this whole idea also seems to be popularized by Hollywood in like a martial arts movie like the Karate Kid or something, where the crusty old teacher is teaching this young guy, and he wants to learn the martial art, but he's making him clean floors or cook food or carry water, and then they show a snippet of like every physical movement that the child made in those menial activities has actually translated into a move within the martial art.
Yeah, exactly.
Right.
So there's a transfer of one skill to another that you may not be aware of
at the time that you're actually doing it.
Yes.
Right. Because and so I'm super excited about this because I saw that as well when we were teaching a lot of kids. And in particular, there's this one instance where there was an older sibling who was mature. I say mature, was like 9 years old, so fairly calm. And his 5-year-old brother used to sometimes come and sit, but on the side. But he was extremely restless. And the mother said to us, "Well, can you teach him?" And I said, "I don't think so, because like, how do you teach 3D printing and CAD to a 5-year-old?" And she said, "Please give it a try." And I said, "Okay." And so we made him sit in front of the computer, and literally as soon as he sat in front of the computer, he did this. I'm bored. I was like, "Oh my god, okay."
Good start.
And I was like, I don't know how to do this, right? But I said, "Okay, let me attempt." And at that time, we were teaching Tinkercad, which is the online CAD tool, very simple. And so we pulled. I opened up a file and pulled a very basic cube shape. And I said, "Do you see the cube?" And I said, "Oh, let me show you something very interesting about it." And he goes, "I bet it's boring." I mean, this kid was real challenged. And I said, "Okay." And I just printed it. I sent it over to a 3D printer. And because it was a small cube, it printed like in 3 minutes. And then I gave it to him. And I think that for him was a penny drop moment. It was like, oh, right. So what I can see on screen can be 3D printed. And then he started making a lot of things. I mean, he made them all with just cubes because he didn't want to learn anything else. So he started making trucks and wheels and everything, but with the cube, right? Which is okay. But he learned. And that's what I found was very interesting for me in that experience, that he started off by saying, "I'm completely bored. I don't want to do this." But once he realized that he can create a physical object, he started to create what he thought was interesting. But in doing that, he started to do things like how to duplicate an object, how to scale an object, which are things that we want to teach. But if I'd started teaching him that, I don't think he had the motivation to see through.
Good point.
So is that an area that you purposefully account, because there used to be a term, I mean, it was very fashionable 10-15 years ago, called gamification, and people try to gamify everything, but is that sort of a idea that you already imbibed into this, or was that a dominant thought initially, or tell us a little bit about that.
So one of the original Thinker Tools programs was a force and motion program where you could create objects on screen and test them as far as force and motion, velocity and impact. And so we had a curriculum based on that, and you would have kids go through the curriculum and do their testing online and write down stuff. And I went into this classroom after school once and set up a little club and just, instead of giving them a real hardcore curriculum, I actually gave them the tools and said, "Hey, let's develop some experiment where we can test what the size of the ball matters, how fast it goes down the hill or something like that." And I had the same problem with one of the students. He says, "Oh, that sounds really boring." And I said, "Okay, well, we're not here to really force you to do anything." So he just looked at the program and then he'd like click something and it rolled down the hill. Oh, wow. And so he just started clicking around, and then he just started he like put 4 or 5 balls down at once, and seeing how far they would collide. And he was just doing all this crazy stuff that we hadn't even planned on, but he got excited about it. And so we realized that whatever tool we build, so somebody's going to do it some kids use it for some other purpose.
Of course, yeah,
Necessarily, and we should be ready. I mean, that should be a feature, I think, of
yeah,
the system. But having it so that the kids can experiment, or students or adults or whoever is using it could actually feel free to use it however they want,
right.
and use it. So, and we're excited to see what actually happens out in the wild, how
Yes,
people use it. And we're developing a message system within our platform so they can message their team members. And I anticipate that that's going to be the best feature, because people are going to be, our kids or whoever's going to be using it, they're going to be on this message system, and
right.
they're going to be maybe talking about their favorite K-pop band. But on the other hand, they may find out that, oh, we can actually develop this tool. We can use this tool to see who's the most popular member of our favorite, BTS.
Yes,
Who's our, and they could create up a game to do that, and they'd be messaging, and we were like, go for it. It's
right, right.
if that helps you learn something about collaborations, how to set up a game to learn something. You may use it, like you said. That kid was just using cubes, but eventually he may be an automotive designer.
And I think nobody's going to dispute the fact that learning is very individual. I mean, there's this extremely popular video by Sir Ken Robinson. He's now passed away, sadly, but one of my heroes in terms of how he describes one thing he does say is just blame the British for messing up everybody's education system. But at the core of what he described was how the modern education system is designed for colonial times, because the British needed bureaucracies all over the world, right? And they followed this sort of factory-style system where the age became more important of the child and stuff. So I know this is not the area that we're wanting to address, but that is why there's a lot of roadblocks for learning. And in this world where the child is getting information from so many different places, I feel like accounting for how they learn and giving them that ownership and agency over the process is incredibly valuable. I mean, it's a big problem. I mean, both as an educator and as a parent, I've seen it firsthand.
Sure.
Right. So I think that's an incredibly valuable thing that you're wanting to put out. I mean, it's fantastic.
Well, thanks. Agency is a good word. Giving agency back to the learner. I think. Well, unfortunately, a lot of learning has been quantified, testing, that kind of thing. So if we can get kids excited, there's so about learning themselves. Or I think when kids are young, they learn naturally. They're just that curious, and we can build that into our tools, build that into our maker spaces. I think that will go a long way to help them get excited about it, and along the way learn some fundamental knowledge that's important. I think I agree with you completely. That's a critical piece that is not necessarily involved in all formal education, and it's not necessarily easy to do, and it has to be sort of planned for, but you have to also be surprised what's happening, and let that work too.
Yes, I mean it's I think it's incredible. It's an incredibly challenging problem, but it's definitely something, if addressed, even if it's not completely resolved, I think any part of it being addressed is going to be valuable to society.
Right. Yeah.
So no, it's a very, not just a noble, but a really important tool that you're looking to provide. So let me kind of towards the end, like, what metrics are you thinking, say within the first 3 months, 6 months, or maybe even the first month, that the tool's been successful?
Thank you for that question. That's something we've been so focused on getting this stuff out there that we are now thinking about that in a lot of different ways. Okay. We're looking at that some number of users is, that's a given, but how many, what's their engagement with the system? Are they playing games? Are they creating their own games? Are they bringing other people online to help them play? Because everything in the web of inquiry are the Thinker Tools platforms is team based.
Right.
Well, you can be a team of one if you if you you're an introvert and don't want to get involved. But so how are you bringing? Are you creating teams? Are you using it at work? Are you using it at school? We have some teachers already online are willing to test it in schools. How is this being used in your classroom? I think fundamentally, in the end, it's like what the highest level kind of questions, like what problems are being solved, what new knowledge has been created that could help solve real problems. How do you measure that? I don't know yet.
Okay.
I think it's one of those things. Maybe we'll know it when we see it, but there's other factors involved in it. Pragmatic things too, like what do we show a granting agency that it's
of course
this was worth their money, or a donor? How to like a donor for a for-profit startup, has maybe different expectations than a donor for a non-profit. They want to see more quality. They want to see more goals that would be in line with their vision of the world, perhaps. I think I'm excited to see what's going to happen. To tell you the truth, the metrics are really critical, and we're still trying to figure that out. To tell you the truth, we're from a research. We're all from research backgrounds, so we know how to set up a research question and get a statistical answer in some way or another. Like my one of my main interests is in individual differences. So especially goal orientation. So if you come to something, a situation or a makerspace or whatever you're trying to do, you have a goal, and the goals can be either more concrete or more abstract, or you can be more task oriented. Like I was assigned this project. I just need to get it done. So I came to this makerspace
to do it. Yeah.
Some people are knowledge oriented. They really want to understand how this works. So you kind of have, and the knowledge-oriented person may get bad grades in school because they're so involved in learning that they're not following up on the task.
Yes.
The task-oriented person could get straight A's but not really be knowledge-oriented. Yeah. I'm guilty of kind of both sometimes. Yes. Sometimes in school I was like, oh, I just want to just tell me what I need to know for the test. I have to get out of here. Another class, I really love this hydraulics. I was an engineer. I really love this hydraulics class, understanding how dams work and spillways. And I would spend more time doing that, and but not necessarily following up on the homework So I may not have done as well. But so I look at those kinds of things. So metric-wise, it'd be nice to. We may have to do some real more formal studies to satisfy like an NSF grant. We may actually have to set up like one classroom using our tool and one classroom not using our tool, and seeing what the differences are. That would be one metric that we could do. But I think fundamentally, we want to have the reach of Wikipedia. I think that's our ultimate metric, and have a real broad range of users, a whole constellation of games being played. We want to have a screen going on. It's there's 1,600 games being played right now. These two are. Look, there's a little bubble of how does AI affect health issues. That's a real bubble right now.
Right.
So to get enough people playing those games to see what's actually happening and what's working. We could have some 6th grade science classroom over here in Upland or Ontario or Claremont, and they say, hey, we want to help you understand how manga could be used for helping people learn about let's say some health issue or some climate issue. We want to help researchers do that. So we would like to see little pop-ups of games tied to some more heavy-duty research. Maybe, I don't know. We want to. That's kind of our metric. Is that the ultimate? I'm not sure. Like, it's hard to say. Like, oh, we want 1 million users playing 2,000 games a day or something like that. That would be great, but it's hard to say where it'll all go.
No, and again, I appreciate you trying. I know that this if you hadn't formed an answer for it, or it really did not identify an answer. You discussing your idea. So I appreciate it. But one of the other reasons I said is hopefully one of our viewers or listeners might have ideas and they can contribute. Because there are a lot of makerspace founders here who listen to the Be a Maker Club podcast. So hopefully you can get ideas and contributions from them.
Oh, that'd be super. So what would so at some makerspace, what would you see incorporating Thinker tools? What would be a success for you? Like that kind of thing. Yeah, with some more real on the ground kind of qualitative or even quantitative kind of data would be great. Yeah. So.
And for everybody out there, I'm going to be posting all the details of the websites and Todd's work, so you'll be able to see it all in the description.
Great, thank you. Appreciate it.
Of course. And with that, thank you very much for giving us this time and opportunity to learn about what you're doing. I wish you all the best. I'm personally super excited. I think you're clearly looking at an area of learning that is fundamentally not addressed. Yeah, I can't wait for this to kind of be out in the public and gain ground.
That's good to hear.
Okay, so I'm going to say thanks to Todd. Thank you very much for being a guest at the Be a Maker Plug podcast.
Thank you.